If y to the negative second power plus 2y to the negative first power minus 15 equals 0, which of the following could be the value of y? Now, I've written out the equation in question here to get a really clear look at it. And doesn't this look like some kind of quadratic equation? Doesn't this look like something where you can factor by making two parentheses and setting it equal to 0 and y, and we're going to come up with a number here and a number here, right? This can't make that big of a difference, right? Maybe it's just a slight change on that. Well, no. No, not really. Not right now, anyway. Now, I'm going to do this in two methods. The first method I'm going to use is going to be the one that most people would attempt. We're going to try and plug in the answers to see which answer gives us a true statement, okay, and that will be our answer. There's nothing stopping us from doing that, but we will have to remember the rules of exponents. So what might something like that look like? How would option A play out? When we plug in 3, and we plug in 3 again, is this going to be true? Well, what does this even mean? This is the review part. We have here a negative exponent, and this does not mean 3 squared. It means 1 over 3 squared. That's what the negative exponents do. They reciprocate the thing inside the parentheses before taking their proper positive exponents. So we continue down this road. We have 2 times 1 over 3 to the first power, then minus 15 equals 0. Now 1 over 3 squared is 1 over 9. And we have here multiplying fractions now. 2 over 1 times 1 over 3 to the first power. That's 2/3 minus 15 equals 0. Well, hopefully we can tell from here that this is not the answer, that this number, tiny 1/9 plus 2/3 minus 15, does not equal 0. It's going to be much less than 0, so it's not this one. So we'll move on. We'll try option B, and we'll see what that looks like. What does it look like when we do 1/5 to the negative second power plus 2 times 1/5 to the negative first power minus 15? Well, this, again, reciprocal before taking the exponent. 1 over 5 becomes 5 over 1 to the second power. All right, we've flipped it, and now we can apply the regular positive exponent, plus 2 times 5 to the first power, reciprocal, minus 15. All right, does this equal 0? Well, if this is 5 squared, that's 5 times 5, 25. This is 10, and then minus 15. That doesn't look like it's going to work because that's 35 minus 15. That is 20. And that does not equal 0. Signify that as well. So that's not the correct answer. Moving along, we'll try option C. This time we're going to do negative 1/5. So I'll go ahead and copy this input here. We'll replace the 1/5 with a negative 1/5. Negative 1/5 inside the input parentheses, of course. All right, so this then becomes negative 5 to the second power. Again, reciprocal of negative 1/5 is negative 5 over 1. Plus 2 times negative 5, now to the first power, minus 15. Does this equal 0? Well, negative 5 times negative 5 becomes positive 25. Here we have minus 10. Okay, 2 times negative 5, so we have negative 10, so plus negative 10, minus 10, minus 15. Does this equal 0? Well, that's 25 minus 25. Yes, 25 minus 10 minus 15. So this is 0 equal to 0, which means we can stop here. Okay, we have found an answer, which could be the value, so that does eliminate all the others. Now I did that for purposes of showing you and reviewing with you how the negative exponents work. You got to be very careful with them. It turns out, however, that there is an interesting way of approaching this one that does not involve plugging in. And we actually can turn it into one of those familiar quadratic equation factoring problems. So if you're interested in learning about that, stick around. That's what we'll do next. What I'm about to do might seem a little advanced to some GRE test takers. It depends on your background, okay? And it might not seem like the kind of thing you'd normally try, but I'd be no kind of tutor or teacher or anything like that if I didn't at least show you the most elegant and arguably fastest way of doing this. What if instead of y to the negative second, this said y to the negative 1 squared? You'll recall that by laws of exponents, this is equivalent to this because I just multiply these when you exponentiate other exponents. And likewise, what if I said that this was y to the negative first, well, to the first power, just kind of encased within its own thing. Minus 15 equals 0. And now, who's to say that I can't decide to rename the thing inside this exponent? What if I said that x, a letter I made up, was equal to y to the negative first power? Well, then I'd have something like this. X squared plus 2x minus 15 equals 0. And this, remember the conversation I started at the beginning of this video, this is a regular quadratic equation. We love these, right? Okay, we want to put x, we're going to factor, we want to be able to multiply to negative 15 and add to the number here, 2, and that shouldn't be too hard to come up with. Let me think, that's 3 and 5, some combination of 3 and 5. It's negative 3 and positive 5. That means the two solutions to the equation, setting both sides of this equal to 0. And you arrive at the conclusion that either x is equal to positive 3 or x is equal to negative 5. But remember now, x was equal to y to the negative first power. That means that y is equal to x to the negative first power. So y is either equal to 3 to the negative first power, or it's equal to negative 5 to the negative first power. And these are 1/3 and negative 1/5, respectively. Now I really know that option C was the correct answer, because negative 1/5 is one of the solutions I get when I do this quote-unquote properly, or at least elegantly.